On today's episode, on the road to net zero, consider cogeneration. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Let's face it, energy is everything. How much we use and how we use it defines human life everywhere, from a primitive tribe on a remote island to life in a major city. With an urgent imperative to find other ways to use energy without fossil fuels, we're now seeing widespread engineering concurrency, meaning research, development, and deployment of alternates all happening simultaneously. But with current available technology, many experts have concluded that there's no way to replace fossil fuel use in the decade or two that the Paris Climate Accord's targets require. Now that's just a reality. So knowing this, what do we do? Well, an obvious answer is to use the fossil fuels that we do burn more efficiently. While everyone wants to lower their heating bill by insulating their homes, there is a technology that's been around for decades which makes a lot of sense: cogeneration. The concept is simple. Take a relatively inefficient power plant like an internal combustion engine or a gas turbine and use the waste heat for some useful purpose. The mechanical energy produced by the engine typically spins a generator to make electricity, but there are interesting possibilities for the waste heat. And there's plenty of waste. A truly excellent engine might have 35% thermal efficiency, and as every engineering undergrad learns, efficiency in a heat engine is directly proportional to the delta T between combustion temperature and ambient. Hotter burning means more efficiency, but the materials problem puts a limit on how hot we can burn fuels without melting the machinery. But what can we do with so much waste heat going to ambient? Well, a simple solution is to use it for space heat. And in cooler climates, this not only has the advantage of increasing overall system efficiency, but it provides grid redundancy as well, something Hurricane Ian survivors in Florida would appreciate. A different type of system, a combined cycle system like the Siemens design, uses the waste heat to generate steam, which in turn is cycled through a steam turbine to generate more electricity. Now, both are good ideas, but neither are new. At the dawn of the jet age in the mid-1940s, the need to increase power efficiency in piston engines led the Curtiss-Wright Corporation to develop a remarkable large radial engine called the R3350 turbo compound. Instead of using the familiar exhaust gas-driven turbine to compress intake air, as commonly used in automobiles today, power recovery turbines were geared to the crankshaft, adding up to 550 horsepower at maximum normal operating throttle settings. Now, the system worked, but it was complex and expensive to maintain. With today's materials technology, it's possible to use piston engines or gas turbines running on natural gas using heat recovery systems to reduce overall fossil fuel use while maintaining normal electrical loads and space heat requirements for many commercial buildings. But could it be downscaled for use in residential homes? Well, there's no technical reason why not, and the possibility of replacing the engine radiator with a heat exchanger mounted where a furnace would be is intriguing. With engine coolant routed through room radiators, it might even be practical to simply distribute the heat the way it was done with boilers a century ago. If the generators were grid connected with control software, they could operate as a gigantic decentralized power plant, stabilizing the grid and hardening it significantly against natural disasters. Selling excess power back to the utility could defray some of the operating cost. So why isn't this happening in a big way? Well, I expect it would be expensive, but I think politics has more to do with it. The perfect is the enemy of the good, and in greenhouse gas reduction, no one seems to want to take practical, sensible intermediate steps that burn less fossil fuel but still burn it. And this is what happens when we let politicians do the engineer's job. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.